Today we're talking about the rule of 4. So we're just looking at a table, a graph, an equation, and a verbal description of one parabola and kind of comparing them to each other, right? Seeing how they connect. So just a little bit of review, right? Our parabola is what we call the graph of a quadratic. Our axis of symmetry cuts our parabola in half. Our vertex is that minimum or maximum point of our parabola. It's the very center of our parabola. This happens to be a minimum since it's the lowest point. Our y-intercept is where our parabola crosses the y-axis. And then our x-intercepts are the same as our solutions, our roots, and our zeros. So when we solve for x, we're really finding our x-intercepts. Some more vocabulary review. We want to review these properties of A. So if A is positive, then our parabola is going to open up, and we'll have a minimum for our vertex. If A is negative, that tells us our parabola is opening down. Okay. Then for our narrower and wider, if the absolute value of A is greater than 1, our parabola is going to be narrower. So say A was 2, that would be narrower than if A was 1. If A was negative 2, that would actually be the same width as A when it's positive 2. It would just be opening the opposite direction. So remember that the negative has nothing to do with how wide or how narrow it is. The negative just tells you if it opens up or down. So then if we want an A value that makes it wider, we would pick something less than 1. So if A was a half, right, that would be wider. And if A was a negative half, that would actually be the same width as a half. It would just be opening the opposite direction. So now that we've reviewed a little bit, let's look at some examples. We have 2 examples we'll go through. So this first one, they gave us the equation. Y equals x minus 2 times x minus 2. Well, notice that we have a double root here, right, because they are both subtracting 2. So that means our x-intercepts are both 2. Again, remember we get these by setting our factors equal to 0 and solving for x. Well, if we graph our x-intercept of 2, 0, right, since they're the same, that means our axis of symmetry passes right through that point. So when we have that double root, not only are our x-intercepts the same, but our x-intercept is also our vertex in this situation. So right now we have 1 point, so we need to find at least 4 more to graph our parabola. So let's start by finding our y-intercept. So if we want to find our y-intercept, we're just going to plug 0 in for x. So we'll have 0 minus 2 times 0 minus 2. Well, that would be negative 2 times negative 2, which is a positive 4. So we have this point 0, 4. So if I go to my graph, here's 0, 4. And then since our parabola is symmetric, I can mirror that across my axis of symmetry, and that gives me a third point, the point 4, 4. So right now we've got 3 points, but we want at least 5. So I'm going to pick an x value, any x value. We've already used 2, 0, and 4, so I'm going to pick 1, right? 1's pretty close to those numbers, so I'm going to substitute 1 in for x. Well, 1 minus 2 is negative 1, and negative 1 times negative 1 is a positive 1. So again, I know it's kind of tough when you have to slide back and forth here, but we're going to graph the point 1, 1, and then we can mirror that to find our 5th point, 3, 1. And then, of course, we need to connect our points here to draw our parabola. So we have our graph, our table, and our equation. So the last step is just to think about this verbal description. So it wants to know if the parabola has a minimum or a maximum. Well, if we look at our graph, it's opening up, so it has this minimum value, right? It's got a lowest value. Then we want to give an A value that would make the parabola wider. Well, remember, it's got to be smaller to be wider. So right now, our A value is 1. So we want our A value to be less than 1. So we could pick 3/4 or a half or 1/4 or 1/5 or 1/16, whatever you want, as long as it's less than 1. I'm going to pick 1/3 because that's less than 1, so that would make our parabola wider. Then last but not least, how would you find the y-intercept, and what is it? Well, we found the y-intercept, right? Up here, they told us to. So we find the y-intercept by plugging 0 in for x. So plug 0 in for x, and that gives you the point 0, right? And then your y value, that's your y-intercept. What is it? Well, your y-intercept is the point where your parabola is crossing your y-axis. That's your y-intercept. And again, we find that by plugging 0 in for x. So that's example 1. Let's look at one more. This time, they gave us a graph. So we're going to look at our graph and use it to fill out the rest of this information. So let's start by looking at our equation, right? Remember, our equation's always in this form: y equals a times x minus p times x minus q. Well, just by looking at our graph, we can figure out our p and our q. We've got our x-intercepts of -4 and -2. So I'm going to let this be p and this be q. It doesn't really matter, right? This can be p, this can be q. So that tells us that we've got x plus 4 times x plus 2. Notice that the signs flip, right? If our solution is -4, then our factor is +4. So we have most of our equation, but we still need to find a. So I'm going to pick another value, any other value. Let's see. I'm going to use my vertex because that looks like a nice point. That looks like the point -3, -1. So that gives me an x and a y value. So I'm going to plug in -1 for y and -3 for x. And now I can solve for a, because a is the only variable. So -3 plus 4 is 1. -3 plus 2 is -1. So we get a times -1, and we divide by -1. We find that a is just a +1. So now we have everything we need to write our equation. Well, we found the a value. It's a +1. So our equation is y equals 1 times x plus 4 times x plus 2. Or, of course, you could just write x plus 4 times x plus 2. That would be fine. All right, so we're halfway done here. Now for our table, we can also just look at our graph to fill that out. Right, we've got our vertex -3, -1, and we've got our x-intercepts -4, 0, and -2, 0. And then let's see, here's another point, -5, 3. And then its symmetric point over here is on -1, 3. And there's our table. Remember, you always want at least 5 points. So last but not least, our verbal description. Does the parabola have a minimum or a maximum? Well, again, this one's opening up, so it's got a minimum. It's got that lowest possible value. And then our parabola, is going up forever and ever and ever, right? So it's always increasing, so that's why we have that minimum value. When it opens down, that's when it has the maximum. We also want to write the equation of a parabola that opens the opposite direction. So since this one was opening up, we want it to open down. So we're going to need a negative a value. Has one solution in common. So our solutions were -4 and -2. So we want to use x plus 4 or x plus 2, right? One or the other. And then is wider. So since our a value is 1, we need a value less than 1. So we could pick anything less than 1. So remember, there's always going to be a lot of different options when you're doing these examples. So I'm just going to make one up. I need a negative a. I need a value less than 1. So I could pick, right, basically any fraction. I'm going to pick a fourth, because I can. You could have done a third or a half or 3/4 or whatever you wanted. And then I'm going to use one of these, either x plus 4 or x plus 2. I'm going to use x plus 4 just because I can, and then I get to make up whatever I want for my last one. I'll do x minus 17. So that is one of many, many examples of an equation that fits those three criteria. And that's our rule of 4. Basically, it's just a review of everything we've done, right? It's just looking at it all at once instead of looking at it individually.